Hey guys, Miss Miklos here. Today's lecture is everybody's favorite word problems. Yay! So, the first thing that I want to point out is that today, since this is obviously doing word problems in our chapter that deals with systems of equations, every single problem we should do today, we should have two variables. And in order to solve two variables, we need to have two equations. So our first thing in every problem is going to be defining what our two variables are. Then, once we figure that out, we will go ahead and write our two equations. So problem number 1, a pumpkin patch has a total of 70 pumpkins. I'm underlining because I think that's going to be important, which sell at two different prices, $2 and $3.50. If all of the pumpkins are worth a total of $188, how many of each type of pumpkins are there? So in this particular problem, we have two different types of pumpkins. We have our big pumpkin here, which I'm going to call X, and that is the one that costs $3.50. And then we have our little pumpkin, which I'm going to call Y, and that is going to be the one that is worth $2 a piece. So now that we have defined our two different variables, I need to write my equations. My first equation, it tells me that there's a total of 70 pumpkins, so I'm going to say X plus Y is equal to 70. My second piece of information tells me that they are worth a total of $188. So I'm going to say 3.5x because I know for each pumpkin that we sell, that's the bigger pumpkin, we're going to charge $3.50 plus 2y equals 188. So now looking at this system, I can solve using whatever method I want to. Looking at this particular equation, or this system I should say, I would probably either use linear combination or use substitution. I think both of those would be equally easy. Cramer's rule would also be an easy choice because we have standard form. Graphing would be awful because of these ginormous numbers. So I'm going to use linear combination. So I'm going to cancel out my y, so I'm going to multiply this top equation by -2, which becomes negative 2x minus 2y equals negative 140. Now I'm going to add these together. I know my y's cancel out, and I have 1.5x equals 48. To isolate x, I need to divide both sides by 1.5. And I get x is equal to 32. So that tells me that we sold 32 of the big pumpkins that cost $3.50. Now I need to figure out how many of the little pumpkins did we sell. So I'm going to use this equation, x plus y equals 70, because it looks a lot easier to deal with in the second equation. And I'm substituting 32 in for x. So I end up getting y is equal to 38. Now this time I do not have an ordered pair. We're answering problems here. So I'm going to say 32 $3.50 pumpkins and 38 $2 pumpkins. Now, just like every other lesson that we've learned in this chapter, I know I can double check my answers by substituting these numbers back into my two equations. The only thing that is going to be slightly different this time is I need to make sure that my system of equations is accurate as well, because we actually wrote that system. So moving on to number 2, just a heads up, I think number 2 is the most difficult word problem that we're going to face. It says, an Honors Algebra 2 class wants to visit the birthplace of the world-renowned Mr. Kramer. We love Subtract Baby so much we want to visit him. They bore An Alaska Airlines jet, which against a given headwind travels the 3,600 miles in 9 hours. Flying in the opposite direction with the same wind blowing, the airplane can fly the same distance in 1 hour less time. Find both the airplane's airspeed and wind speed. So some things that I think are going to be important are the 3,600 miles, 9 hours, 1 hour less time, and airspeed and wind speed. So right away, I'm going to say x is equal to the airspeed and y equals the wind speed. The other piece of information that is important is that we have previously learned this equation of distance is equal to rate times time. And that is going to help us figure out our two equations here. So I'm actually going to go ahead and make a chart. So my chart's going to look something like this. We have our rate times our time, and that's going to give us our distance. Now, some of you might be thinking, but the distance is 3,600, and you're correct, but we're actually going to use that later on in our problem. Okay, so the rate there, on the way, it says we're going against a given headwind. So I just want us to think for a second. If you are out on the field running against the wind, is that going to make you faster or make you slower? And obviously it is going to make us slower. It's going to make our rate smaller. So it's going to be the airspeed minus the wind speed. I'm told that this is going to take 9 hours, so I'm going to say that our distance is 9 times the quantity x minus y, because I know rate times time equals distance. On the way back, with the same headwind blowing, this time I'm going with the wind, so it's going to make me faster, so I'm going to add their rates together. The time, it says it takes 1 hour less time, so I'm going to write that that is 8 hours. And I have 8 times x plus y. Now, this is going to help us write our equations because I know 9 times x minus y is the distance, but they tell us the distance is also 3,600. I could also write this equation, if we wanted to, as x minus y equals 400. What I did there, I divided both sides by 9 to get the x minus y all by itself. I think that's going to make life easier. My second equation, I know 8 plus the quantity xy is also equal to 3,600. And if I divided both sides by 8 there, I get x plus y equals 450. Now, to me, this looks like it was made to use linear combination because my y's are already opposites. So when I add these together, I get 2x equals 850. So x is equal to 425. Now, to figure out what my y value is, I'm going to use the second equation here. 425 plus y equals 450. So I get y equals 25. So now I need to actually answer the question. We're going to say 425 miles per hour is the airspeed. The wind speed is 25 miles per hour. So we went ahead and found both of those. Now keep in mind, even though I used this particular method, we could have used Cramer's rule, we could have used substitution. You can use whatever method you think is easiest. Last but not least, let's do number 3. It says, by the way, if you haven't noticed, these are all Halloween themed word problems, and that's because we're getting into October here, so just an FYI. Number 3, the image of a witch, and we're going to use this lovely dog with the witch hat on, has been placed on the side of the building, so we're going to pretend, didn't mean to do that there, here we go. we're going to pretend this is the building and we see this witch on it. And voila, the shape of the witch's hat is in the shape of an isosceles triangle. The perimeter is 50 feet. If the length of each congruent side is 10 feet shorter than 3 times the length of the base, find the lengths of the 3 sides. So some things we know that isosceles triangles are 2 sides are congruent. So we're going to call those sides X. I'm going to call the other side Y. And it actually tells us that the perimeter is 50 feet. So I know X plus Y equals 50. The other equation says the length of each congruent side is 10 feet shorter than, so I'm going to say X is 10 feet shorter than, I know I'm going to have to do something minus 10, and it is 3 times the length of the base. So looking at this, okay, I know my first equation is really 2x plus y equals 50. To me, it definitely looks like we should be using substitution here because I already have x isolated for itself. So I'm going to do 2 times 3y minus 10 plus y equals 50. 6y minus 20 plus y equals 50. 7y minus 20 equals 50. 7y equals 70, so y is equal to 10. So now if I have y equals 10, I can substitute that into our other equation. So I get 3 times 10 minus 10. So I get 30 minus 10, which is 20. So it says find the length of the 3 sides. So we're going to say 20 feet, and 10 feet. Once again, if I wanted to, I could double check those. And that's about it. I would say that this worksheet that you're going to do for the suggested problems is probably the most difficult assignment of this chapter. I would definitely practice doing a few of them before you guys do your walkthrough.